Hello, and this is still week 6 of the graphics class. And today I'm going to give you a refresher course, or more of an introduction to 3D printing, because that goes back to the objects assignment. Now the semester is only so long, and so we really have to start talking about that objects assignment sooner rather than later. I've already introduced it, I've talked about it a few times, but I want to give you as much as possible in terms of the applications, because each of those objects represents an application. And so that's what we're going to talk about today. And the first application that we're going to formally introduce is the 3D printer. Now, one of the reasons why that we're doing this one first is because a lot of what we've talked about so far has had to do with making models in the modeler program, and that is all you need for the 3D printer. You've got your models, and instead of taking them into layout, you would just bring them right into the 3D printer and print them, and it's as simple as that. Or not quite that simple. And so this goes to the object assignment, as we say. And remember, you're expected to make 4 objects, and the 3D printed object could be one of them. And so this could be something that you could enjoy doing. And 3D printing allows you to design physical objects. I mean, you can make things out of thin air, really. Designed on the model program and printed out. Now, it's important to make a distinction here is that this would not be an exercise, this would be a project. An exercise is when you say, gee, I wonder if I could print this out, and just basically make a sphere. Can I print a sphere? Yes, you can print a sphere, but that's not the project. Project is, what can I print out on a 3D printer that's good? You know, that's worth printing, and we'll talk about that as we go along. Now, it's all about plastic. That is the one, it could be considered a limitation of the 3D printer. Let me just fix this over here. There we go, 3D printed assignment. I'll put myself there. It could be a limitation of the 3D printer that we have to work with plastic. We can't 3D print metal or glass or anything like that. We're limited to something called PLA filament. And you'll see that in the accompanying video, which talks about how this is actually done. And so plastic, you can make anything that you can imagine out of plastic. So it can be hollow plastic, it can be filled plastic. So here's one example which I'll show you more. This is a hollow object, whereas this would be a solid object. And you can choose any color you want. You've got all the basics. We got red, we got purple, we got yellow, we got gray, we got black, we got white. And so whatever it is that you want, if you think you're going to need a significant quantity, we can even arrange to get you some. That's no problem. Okay, so I want you to think in terms of making prototypes. Now, what's a prototype? If you were to invent something, let's say that you had an idea for some new toy or some new gadget, then you would have an idea, then you'd write that out as a plan. At some point, someone's going to say, well, I need to see this thing in action. A prototype is usually the first version of whatever that is. And so, for example, when Henry Ford made the Model T, there must have been the very first Model T. It probably wasn't made on the assembly line, and it probably took far more time to make than the ones that came off several hundred per day or whatever. And so the idea is that the prototype is something that you put a lot of time into, but then there it is, and that's what you show around, and then you know how to do it. And so this is a way of demonstrating your idea for a product if you have one. And why not? Test it out, see if it works. Improve on it. Let's say you look at the prototype and say, you know what, this works, but I didn't consider this. I didn't consider it's too big, it's too small, it doesn't fit into my pocket. And so if something, it's got a sharp edge on it, that's something that's easy enough to fix. And if you don't like it, fix it. That's the idea. You can redesign it, reprint it, and so that is better. Don't be afraid to experiment. That's why this is so incredible. It's originally, before we had 3D printing, you might have to make something out of wood. You may have to carve something, or you may have to cast something, and that can be very expensive. You may have to hire someone to do this. Whereas the 3D printer, you just push a button and it does it for you. You can't say fairer than that. Now, the rules of the game for this project The rules of the game. First, all prints have to be original. So that means you cannot reach out to the Thingiverse and print something out from there. I mean, you could, but not for the assignment. Meaning that if you say, gee, I'd like something from Marvel Comics, and you find something in the print universe, you find a beautiful Spider-Man statue and print that out. Well, you printed out something that somebody else designed. What I want you to do is design something and print it out for yourself. All prints must be printed, meaning that I have to see it in actual physical form before I can grade it. So it can't just be an idea for something to print. You've actually got to print it out, and it's actually got to be good. And they should be print worthy. And so if all you got is a sphere with eyes on it or something like that, I wouldn't really call that print worthy. I would say you can do better than that. So in other words, it can't just be a primitive, or a half-baked object. It's got to be something that actually does something, that actually has some character in itself and could possibly be useful, even if it's jewelry or art or something like that. It can include multiple parts. It can include interlocking parts. Some things, as you'll see, are too big to print on their own, so they may need a little help. And so there's ways of doing that, which we'll go over. Okay, and to show you some examples of things that you can design. For example, we have this device here, and this was a prototype that was made using the 3D printer. And you can see it's got more than one piece. In fact, it's got a few pieces there. And just the one that fell off, let me demonstrate that first. Here's a little blue button, fits into this little hole here. And just to show you, these things aren't perfect, but that is supposed to prevent those screws from falling out the end. And so what this is, just to give you an idea, is if I loosen this and I push the button, make sure, then this is a camera plate that fits on the bottom of a professional video camera. And then when your camera's on here, you would slide the plate into, if this were onto a surface somewhere, you would slide the camera, plate and all, into this, and that still comes out. And you can see it doesn't come out. The screws would be tied to the camera, so that wouldn't affect. But if you tighten this, then you can lock the camera into various positions. And then, of course, to get the camera out of there again, you would push the blue button, and when you push the blue button, it comes out. See? And so you might wonder, what does something like that look like to design? Well, this is what it looks like. So if you look at in Modeler, that's all it is. Now here you're seeing the whole thing. If I were to only look at the first layer, because each of these was designed in a single layer, you'll see that is the tripod mount itself, which is this thing. And you can see it looks exactly like that. And on the bottom of this, you can even see all of the details, which are shown here as well. And that's how it fits into the appropriate mechanism. And then if you go up one layer, you will see this, which is the top part of the receptacle that it goes into. And this is all one piece. This was printed out in all one piece of solid plastic, and you can see that all the necessary parts are in there. Now if I go to the next layer up and I turn that on, it might be easier if I turn it this way. And if I hold down the shift key, I can put both on at the same time. You can see that's where that little button operates. And so if I'm up here, you can see there's the button. And so if I turn it off and turn it on again, that fits into there. And if you look at it from underneath, you can even see how that works. And so there it is. And so that's where that spring would go. There's a spring that keeps it in the out position. And the very last layer cements that into place. And so if we turn that off and put it on as a background, you can see where that just fits onto the bottom. It just snaps in place and holds the plate together. And lastly, this other layer, if I hold down the shift key, just turn it on, that is the wedge that clamps the camera into place. So if I just go, well, it's there. It's right there. That secures the camera. And so that's how the thing works. And that was basically nothing more than a series of boxes that were carved up using Boolean subtract and then printed. And I also had something really simple here. This is my nice little dice game. And so here, you've got a dice within a dice, or a die within a die. You've got this 12-sided dice on the outside, and on the inside you've got a regular 6-sided die. And you just roll the dice, and that's how it works. And this was based on something I wanted to make as part of an animation where you can see the actual die in motion there, and then it falls into the box. And you can see what number it comes up. It came up 11, but on the inside there's another die inside. And so that's what this was based on, so why not? And as you can see, here is the model of the die, which is nothing more than an octagonal shape, or however many sides that was, whatever type of shape that was. And then I just basically subtracted it from itself and gave it that smooth edge there. And then I just basically Boolean subtracted the numbers, and lo and behold, you've got this device, which I then put right into the MakerBot software. And lastly, just to show that you can do just about anything, this was an actual model that I printed out that was based on a story that I'd written in a spaceship. And so this was probably the third version, because I really wanted to get the detail right. I wanted to be able to read the word Ultra Blitz, which admittedly the 3D printer has some limitations, but this is too big to fit in the printer. This had to be printed in pieces, and so literally every two edges here have to be printed separately, and they're ultimately glued together, and that's how this was created. And so you could print something like this if you want to, and this doesn't do anything. It's not a prototype. It's just a work of art. It's a model, something I felt like doing, and that would count as well. Okay, so how would you do this? Well, first of all, what you do is you work in Modeler only. You don't have to do anything else besides that. Modeler is the only program you need to use. No surfaces are needed. You don't have to worry about designing smooth surfaces, rough surfaces, anything like that. Pretty much it's just geometry, just whatever is the model contains. You do not have the ability to add smoothing, for example, or things like that. No camera angles, no fine positioning of lights or anything like that. Basically, you just export the model as a single layer as an STL file. Has to be a single layer, by the way, so sometimes that means you may have to compress it, or you may have to print it out in pieces. And the MakerBot desktop program receives the file, and then you just fine-tune in size and position, and then of course you just preview it and print it. I save the print file and take that to the MakerBot printer and put it in, and basically turn it on. And the second video I have will demonstrate that. But before we do that, let's take a look at how we could do this with some of these examples. Okay, so in this example here, what I have is literally a phone holder. And so if you look here, the phone would fit into that slot on top, and then you would be able to see the phone through this window, and the back of this is supposed to clamp on to an arm, that suction cups to the car windshield. And so, long story short, I bought one of those things, and it got a different phone, and the different phone wouldn't fit the old holder, so this was my solution. I made a new one that would fit into the same exact receptacle that the old one would, and guess what? It worked. Okay, so let's say I wanted to print this out right now. What I would do, this is a model with one layer, it's only one object, all done through Boolean subtract, very easy. Doesn't even have smooth edges. It was all very roughly done. And then I would just go up here and I would export it as an STL using the export STL file. And then just say OK. And we'll put it in the same place as the rest of the class stuff. And we'll call this phone, for lack of a better term. And I hit OK, and that's done. And so then it will go into the MakerBot software. And so here is our MakerBot software. Now notice it's got this floor plate here. It's designed to simulate a three-dimensional perspective. This looks like a fish tank or like a hamster cage. Basic rule: you can't print out anything that doesn't fit in the cage. And so you may have to fine-tune it to make that happen. And all I'm going to do here is I'm just going to add a file to this, which is the one we just did. So if I hit Add File, it's going to look for files. And you see there is the one I just made, phone.stl. I hit OK. And it's asking me to rescale the object. Usually that means it's got some reservations about the size. I'm going to say go ahead and rescale it just to see what it does. Okay, so here we got a little bit of a problem, but not something that's impossible to fix. So you notice that little bitty spot there, that's the object. And chances are that's not going to be big enough. So there's only a few controls on this thing. It's actually very easy software to use. And if I go to this control here, that's the scale control. And if I hit it twice, you can see that the object is coming in at 3 millimeters. So I'm going to say that that's not the dimension I want. So I would just, especially if you're doing a prototype, you should know exactly what the size should be. So let's say I'm going to call that 300 millimeters, which may actually be too big. Oh yeah, it is too big. So let's make that 30 millimeters instead, which would be basically 3 centimeters. Yeah. And maybe that's 2. So what I'll do is, see, this is why it's such a good program. That's the wrong axis. So I would apply the 30 centimeters here, or 30 millimeters here on the y-axis instead of the x-axis. And that's probably about where it would be. And so that lands there. And so then, if I got the size right, and you can get it down to anything you want, so it'll print out exactly the size. And then if I go to this control here, this allows me to rotate it. And so I can see it, I can rotate it to where I want it to print. Now, one of the reasons why you want to do that, and you hit lay flat, notice it's below the level of the plate. You have to lay flat, otherwise it won't work. And then you can even rotate it if you want to get a better view of it. Simply put, the printer prints from bottom to top. If there's some critical surface on the bottom, you may want to flip it. You may want the critical stuff to be on top because it doesn't have to have the entire weight of the model on it. Because if there's a lot of details there, that may look rough, because the bottom surface may look rougher than the rest of it. Same thing with the sides. It may be better to print it vertically instead of horizontally. But there it is. And then, of course, if you wanted to, you could go up here and position this. If you were printing out 4 of these things, you might position them in different quadrants. I recommend that you don't do that. Every time I've done that, they always come out bad because they get stringy. There's strings going between them. So the thing needs all the help it can get. Then when you're happy with the positioning and everything, just hit the preview button, and what it will do is it will do all the calculations. And you can see right on there. See, it's doing its thinking, and it may take a second. Oh, not that long. And it gives you this, and you can look around here. This, and the mouse wheel allows me to go in on this. It's not very easy to interpret, but you can see that's going to be the base. It creates something, I call it a sled, that it fits the object onto, so that it doesn't print directly onto the tape. And so then you peel that off when you're done. And I don't see any problems with the print For example, this hole might get filled in. If one of the holes was filled in, this is where you would see it. And so you might want to check the preview. You can also see what's going to happen as it prints. So if you look at the different layers, you can see what it's going to do at different stages of the print, because it goes from bottom to top. And then when you're ready, just hit export, and notice it will say phone.makerbot. And if I hit save, there it is, and it just says phone has been saved. And so you see here, that's the file that you put on your thumb drive and take it to the 3D printer and run the print. And so that's basically it. That's what I'm going to expect you to do if you want to do the 3D printed object as one of your objects. But it is definitely worth looking into if you want to create something of interest.